important. Now LPC2148 has got two UARTs, UART 0 and UART 1, and we are using UART 0. Now UART 0, the important registers are U0 LCR, line control register. Using this register you are going to define the format of the data. Now that is you are saying 8 sequence of 8 bits form a byte, and you are saying by making the second bit as 0, you are saying there should be one stop bit, and you are enabling the device latch access bit. And then you understood U0 DLL, UART 0, divisor latch least, UART 0, divisor latch most. So these are the two registers, again 8-bit registers, which you need to compute. Just to compute in order to bring down the CPU clock frequency such that it can make the peripheral devices run. These are the two registers again, and this here I explain how to find U0 DLM and U0 DLL. So later in my program, I'll show you this value. I'll just try to modify this value and show you will not get the proper output because the peripherals cannot operate with that clock frequency. Next. Now U0 THR, and this is the register, transmit holding register. The data which you want to send should be assigned to this U0 THR. And one important thing is, before assigning the data to this register, so DLAB should be made as 0. You'll be making this DLAB as 1 in order to define the data format. After the data format is done, and after you compute the U0 DLN and U0 DLM, so just make this back to 0. And then one more register which we'll be using is U0 LSR, line status register, just to check whether the data transmission, the data transfer is completed or not. If the 5th bit of this particular register is 0, data transfer is not yet completed. If the 5th bit of this register is 0, the data transfer is completed. U0 THR is empty, is nothing but the data transfer is complete. Now the registers which you got to remember is, one is LCR, line control register, which you are using in order to define the data format. So there the least two significant bits, 0 bit and 1 bit, you are making them as 1 1, and the second bit is made as 0, just to say use one stop bit, and the 7th bit is made as 1. The moment you make 7th bit as 1, it will enable you to use U0 DLL and U0 DLM. And next is computing U0 DLL and U0 DLM. Now to compute them by using the formula U0 DLM plus U0 DLL is equal to PLCK divided by desired baud rate into 16, and PLCK can be found by dividing the CCLK by 4. CCLK is CPU clock frequency is 12 MHz, 12 by 4 it is 3 MHz. Now you substitute there, simplify, we got 19, and 19.5 fraction I ignored, I considered only 19, and 19 when I convert it into hexadecimal I got it as 13. Now and this 13, which register it should go? It should go to U0 DLL. And what about U0 DLM? It is 00. So with that I have found. Okay, next. Now we'll go to the and next register is required is U0 THR. U0 THR is transmit holding register, to which you'll be assigning the data that needs to be transferred from one device to the another device. And later one more register is line status register. Using this register, especially using the 5th bit of register, you can know whether the data transfer is complete or not. Now if the 5th bit of LSR register is 0, the data transfer is not yet complete. If the 5th bit of LSR register is 1, so it indicates the data transfer is completed. Next we'll go to the program. So this is the UART program. Now as usual we are including the header file lpc214x.h, and then these are this is the function which I have in my program. This is the prototype for it. I have a function with the name UART underscore initialize, because I want to do initialize the UART, because void. Now what kind of initialization we do, because I have to select the transmitter port from the LPC2148 and the receiver port from LPC2148. So port pin, transmitter port pin and receiver port pin from LPC to 148, that is what I do. And after that I define the data format, so using LCR, line control register, which I explained in the previous slide. And after that we compute the LCR. I already have computed that is 0013 I got. U0 DLM is 00 and U0 DLL is 13. So that we assign in this function, and after that we make DLAB as 0, and then we go for writing the data to U0 THR. After writing data to the U0 THR, we check whether the data is sent to the other device by using the 5th bit of LSR, line status register. Okay, the one function with the name UART initial. I'll explain this later when I go there. And then one more global variable with the name delay. I have a character pointer star PTR. Now this is my message, hello world, and /n is there, new line. So this is my message. This is what I want to display using internal UART. Now int main and while, because I'm writing this inside the while loop, while 1 is there inside the while loop. Now I want this hello world message to be displayed infinite number of times. Okay, now I'm calling inside the while loop, I'm calling UART initialize. Let me go to that function UART initialize. This is very important to understand here. UART initialize. Now pin cell 0 is equal to, this is what I'm assigning. Pin cell 0 is a 32-bit register, and this is the data which I'm giving. I'm just writing for this particular digit 0, and 5 in binary is what? 0 1 0 1 0 1 0 1. Now to select the transmitter and the receiver lines. Now in the previous classes I explained, P0.0 acts as the transmitter and P0.1 acts as the receiver. Now how to make, if I make these two 0 0, P0.0 acts in the general purpose input output mode. If I give it as 0 1, so P0.0 acts as the transmitter, and similarly now if I give this bit also 0 0, you have 0.1 acting as GP in GPIO mode, but I don't want it to operate in the GPIO mode. I want it to access the receiver. When I give 0 1 to the second bit and the third bit of pin cell 0, you have P0.1 functioning as the receiver. Now we have P0.0 functioning as transmitter and P0.1 functioning as receiver. That is what I'm doing. Remember now, P0.0 is used as transmitter, P0.1 is used as receiver. And next observe this, U0 LCR. What is LCR? Line control register, which is used in order to define the data format. Now what is the data now? 83. So that is what I showed you here. 83. Why 83? Because these two we are making 1 and 1 just to tell 8-bit sequence makes a byte, and so this we are making it as 0 because I want to use only one stop bit, and this we are making it as 1 because I want the divisor latch access bit to be enabled. Now with that, so this is how it comes 83. So now I'm assigning it to U0 LCR. This is again 8-bit register 83. Now I've written here also 1 0 0 0. This is 8, 1 0 0 0 is 8, and 0 0 1 1 is 3. Now what this data is saying, 8-bit data, one stop bit, and enable divisor latch. Now and next is setting the U0 DLM, computing U0 DLM and U0 DLL. Now I've already computed it here. Now I've computed that U0 DLM value is 0 0 and U0 DLL value is 13. Now that is what I'm assigning here. Now U0 is assigned 0 0 is assigned to U0 DLM and U0 DLL. That is UART 0, divisor latch most, UART 0, divisor latch least 13. Now when I take it, how to read 0 0 1 3 it is. Now by setting this value, we are selecting the baud rate of 9600 bps bits per second. Next is next I have prepared everything. I have selected the transmitter, I have selected the receiver line, and then defined the data format here, and then set the baud rate to 9600 by computing these two values. And next is what I should go for writing the data. Now before writing the data, to which register will be writing? U0 THR. Before writing the data that needs to be transmitted to U0 THR. So what is that you have to do? You have to disable the divisor latch. Now for disabling the divisor latch, this is the divisor latch bit. If you got to make this as 0. When I make this as 0, what is the data? It is 0, 3. That is what I've given here. I showed it here also. So it is made as 0, 3 divisor latch bit. Now without doing this, it is not possible. Now that is what you are doing inside the UART initialization. The moment the UART is initialized, the control comes here. PTR is equal to array. It was a pointer. Now PTR is also pointing to this array, hello world. Now while PTR not equal to null till the null character is encountered, so PTR is pointing to this H now, and I'll repeat this while loop until PTR points to the null character, end of the string. Now PTR is not equal to null, PTR is pointing to H not equal to null character, true. Now we are inside the while loop, and star PTR plus plus is equal to U0 THR. What is this U0 THR? Transmit holding register. That means now I want to transfer H to the device. Now where I have to write? I have to write it to the U0 THR. Now H is returned to the register U0 THR. Now the moment it is returned, it will start sending to the other device. Now and this is post increment. Now PTR is automatically incremented after H is returned to this register. PTR is automatically incremented and pointing to the next character E. Next, now this while statement with a semicolon is written in order to just check whether the transmission is complete. We have written H to the U0 THR. Check whether this H is already transmitted or not. How do I know? By doing this. Which register will use for that? So line status register. And again, which bit of line status register? 5th bit of line status register. Since it is the 5th bit of the line status register, I have taken it as 40. I am doing the AND operation. Now if the 5th bit of the line status register, when it becomes 1, when it becomes 1, the data transfer is completed. Just to check that, I am using this operation. Now 40, why I have written 40 only? Because when you write this 40 in binary, let me write here. Now when I write, let me write here. Now this 40 in binary I am writing 0, 1, 0, 0 and 1, 2, 3, 4, 4 zeros. This is 4 and this is 0. Now observe here, this is 0th bit. Yeah, let me give space for clarity. Yeah, this is 0th bit, this is first bit, second bit, third bit, fourth bit. Sorry, 0, 1, 2, 3, 4, 5. Yeah, 1 second. 40. This is 4. So this is third bit here. This is fourth bit. This is fifth bit, and this is sixth bit. There, I think it was written from 1. Now we have to make that as if this particular bit is 1. So then and when I do in U0 LSR, if the transmission is complete, as long as the transmission is not complete, so this particular bit will be 0, 0, 0, 0, and again 0, 0, 0, 0. When I do ANDing operation, it's not equal to 0. If it is equal to 0, when I do ANDing operation, it is equal to 0. It loops here only. The moment this particular bit becomes 1, so this 4 and 4, the result is 40 again equal to 0. Condition is false, then it will come out. So this is what we are using. This is just to check whether the fifth bit of I'm deleting it. Whether the fifth bit of line status register is 1 or not. If the fifth bit of line status register is 1, so then the transmission is complete. So you call a small delay, go back to the while loop. PTR is now pointing to E, assign E to U0 THR. Now U0 THR gets E, and again the moment is written, it will transfer. And how do you check? How do you make sure that it is transmitted? By checking the fifth bit of U0 LSR. Now when this condition is satisfied, so as long as this condition is satisfied, keep looping area. That means it is still transmitting. The moment this condition is satisfied, E is transmitted, then with a small delay again go for transmitting E. So like this hello world gets displayed, and since this we are writing inside the while loop, so the hello world will be displayed forever continuously. So this is the program. I hope you people understood the program, and have written the comment also here. Check if U0THR is empty by checking the 5th bit of U0LSR. If the 5th bit is 1, data send is successful. If it is 1, data is already sent. If the 5th bit is 0, data is not yet sent. Okay, now we'll try to execute the same. Let me copy the same program, because I've explained this. If I execute the same program, it will be better. Copy. I've already kept it open. Now I'll just go to project, new Macrovision project. Let me save it on the desktop. I'll create a new folder. New folder. So let me name the folder as UART, and then the project name also let me give it as UART. Now controller LPC2148, this is the controller which we need. Select it, say OK. Now startup.s, because the embedded C program you are writing, startup.s is required, include it. The moment the startup.s is added, just open it, go to configuration wizard and uncheck the PLL setup and save. And now go to new, because I have to write my program. Now I've already copied this program. This I've copied the first slide. Let me paste it here. And the functions is in the next slide. Let me copy that also. This one. Copy. I'm pasting here. Now it is copied and pasted. Let me save the program now. So I'll give the name, program name also as UART.c. So the program is saved. Now I got to add this program to my project. So right click on source group, go to add existing file, select UART C file. You have to observe your C file, add, close. The file is added. So the moment it is added, I can go for compiling it. So compile. So 0 errors and 0 warnings. Next I can go for building. So build is also successful, 0 errors and 0 warnings. Now how do I see the output? Now in the class you'll be using the hardware kit for seeing the output. You'll be dumping this program, get the X file of this, you'll be dumping this to the LPC21 physical LPC2148, and then you run, and inside the flash magic there will be something called as terminal. If you open the terminal, whatever, so now what it is doing, the controller is sending data to the terminal. So controller sends the data to the terminal. Now since I don't have the hardware, so but still this can be simulated. Now I'll go to the debug. Here also you can show the output. Go to the debug. Yeah, and this is not required, the upper one, let me minimize. Okay, now here after going to the debug, just go to view and go to serial window. Here UART1, click. So again I'll show you, let me close this, go to view, serial window, UART1. So this window opens. Let me take it here. Now after this window opens, if you want, you can little maximize it little. Okay, this is enough for me. Then you can go to debug, say run. Now if I say run, my program will run, and you should observe the hello world message here. See, hello world getting printed. Now why multiple times it is coming? So because we have written this inside the while loop. See, this is increasing. See, so it's still writing. Infinite number of times it keeps writing. It's writing. Okay. Let me stop now. I wanted to show you one more thing now.